You know, when you look at these massive, complex applications that professionals build, have you ever wondered how they do it without getting totally lost in a sea of code? Well, a huge part of the answer lies in mastering one really fundamental concept: functions. They're kind of like the secret weapon for writing smarter, cleaner, and way more efficient code. And today, we are going to break down exactly how they work.
All right, be honest. Does this look familiar? That feeling of déjà vu. When you realize you're typing the exact same chunk of code for the third time in a single program. Hey, we've all been there. It's practically a rite of passage for every new programmer, but it's also a big, blinking red flag that there's a much, much better way to get things done. I mean, this slide really tells the whole story, doesn't it? Over on the left, you've got what I call the copy-paste nightmare. It's just a tangled mess that's hard to read, and believe me, it's even harder to maintain. What happens when you need to fix a bug in that code? You have to go hunt it down in every single place you copied it. But on the right, that's the dream. That's our goal: a single, clean, reusable piece of code. So this whole problem of repeating yourself, it actually has a name in the world of programming, and it's basically a cardinal sin. It's called redundancy, and today we're going to learn how to obliterate it. And let me be clear, redundancy isn't just about your code looking a little messy, it is actively harmful. It turns a simple one-line bug fix into a nightmare scavenger hunt, and it makes updating your program a truly painful chore. This is why great programmers are absolutely obsessed with avoiding it, and functions are their weapon of choice. So, how do we fight back against all this chaos? Well, we bring in a little helper. Let's meet the elegant solution to our redundancy problem: the function. Seriously, the best way to think of a function is as a specialist you have on speed dial. Need to calculate a sum? You call your sum specialist. Need to print a cool welcome message? You call the greeting specialist. You define their job one time, and then you can summon them to do that exact job as many times as you want from absolutely anywhere in your code.
So at its heart, every function follows this simple pattern. You give it some ingredients to work with, we call that the input or parameters. The function then follows its set of instructions, that's the process happening in its code body, and finally it hands you back the finished product, that's the output or the return value. Input, process, output. That's the whole game.
All right, that's enough theory. Let's roll up our sleeves and actually see how you build one of these little helpers from scratch.
Building a function is kind of like filling out a work order for a robot. Every single C++ function needs these 4 key pieces of information. First, the return type. What do you expect to get back? Second, the function name. What's its unique name so we can call it? Third, the parameters. What materials does it need to do its job? And fourth, the function body. This is where you write the step-by-step instructions. Let's see this in action with a super simple example. Say hello to print hello. Its return type is void. That's a special keyword that just means, hey, this function doesn't give anything back, it just does something. Its name, obviously, is print hello. Its parameter list is empty because it doesn't need any input to do its job. And its body has just one instruction: print hello. See? It's really that straightforward.
Okay, this next point is absolutely crucial. You've designed your helper, you've written down all its instructions, but right now, it's just sitting there, waiting. A function does absolutely nothing until it is called into action.
This recipe analogy is just perfect. Defining a function, that's like writing down the recipe for a cake. You have all the instructions, but there's no cake yet. Calling the function is the moment you actually preheat the oven and start cooking. It's the command that says go, do the thing, and executes the recipe to produce a result.
Okay, here's a little bit of vocabulary that trips up almost everyone at first. So let's clear it up. Parameters versus arguments. Think of it like this. The parameters are the ingredient list in your recipe. They're placeholders like amount of flour or type of sugar. The arguments are the actual ingredients you use when you start cooking, like 2 cups of flour or brown sugar. Parameters are the blanks, arguments are what you fill them with.
So what's actually happening inside the computer's memory when you call a function? I mean, how does it keep track of everything? This is where things get really, really cool.
So where do these functions actually go when they're running? They don't just execute in some kind of void. The computer uses this really clever system to manage all the activity, and it's called the call stack. The best way to picture the call stack is like a stack of plates at a buffet. When your program starts, the main function is the first plate placed on the stack.
Now, if main calls another function, say sum, a new plate for sum gets placed right on top. The function on the very top of the stack is always the one that's currently in charge. When sum is finished with its job, its plate is taken off the top and control goes back to the plate right below it, in this case, main. It's a last in, first out system, and it's how your program always knows where it left off.
And you know what? This whole stack of plates thing perfectly explains another huge concept in programming called scope. See, any variable you create inside a function, like in our sum function, it lives only on that function's plate. The moment that function finishes and its plate is removed from the stack, poof, all of its variables are wiped away. They are temporary and local, which is why the main function has no clue they ever even existed.
Okay, one more critical detail about how C++ functions work by default. When you give data to a function, you're not actually giving it your original data. You're giving it a photocopy. This is called pass by value, and it's basically a safety feature designed to protect your original variables from being accidentally changed. It's the default behavior, but just so you know, C++ also lets you pass by reference for those times you want a function to modify your original data. But that's a topic for another day.
Let's just trace this code real quick. In our main function, we create a variable x and we set its value to 5. Simple enough. Then we call a function and pass x to it. Now, inside that function, it receives a copy of x and it changes its copy to 10. But, and this is the key, when the function finishes and we come back to main, what's the value of our original x? It's still 5. It was never touched. That is the core takeaway of pass by value. By default, functions can't mess with your original stuff.
So, after all this, why does mastering functions matter so much? Well, it's because learning to use them effectively is what elevates you from someone who just writes code to someone who designs elegant solutions. They really are a programmer's superpower.
When you get right down to it, using functions gives you 4 massive advantages. First, reusability. You write the code once and you can use it forever. Second, readability. Your code becomes clean and almost explains itself. Third, debugging. Instead of hunting for a bug in a giant file, you can isolate the problem inside one small, self-contained function. And finally, modularity. You can break down huge, complex problems into simple, manageable, solvable pieces.
I want you to remember this quote. Good programmers don't repeat themselves. They write functions. This isn't just about saving a few keystrokes. It's a whole philosophy. It's about building solutions that are robust, maintainable, and, well, elegant. Once you master functions, you'll find you've made the leap from just writing lines of code to truly engineering software.